In this video, I'm going to talk about, or I'm going to solve an example based on the Coulomb's law. Here is the example. So, two positively charged particles, Q1 and Q3. So, Q3 is same as 3 times Q1 or 10 centimeter apart on the x-axis. Where could a third charge Q3 be placed so as to experience no net force? So I usually draw a picture to understand it better. So he clearly mentioned two positively charged. So here is charge 1, Q1 and Q2. Q1, he didn't give us the quantity, but he clearly mentioned Q2 is 3 times larger than Q1. They placed on the x-axis. Okay. So the question he's asking about, where do you keep a third charge Q3 to have zero net force on it? So for sure Q3 must be on the same axis, then only the net force is going to be zero. What happens if I keep that charge right here? Okay, if I keep this charge right here, okay, did he mention what kind of charge is that? He didn't. For time being, I'm going to take this as positive charge. Then what happens? Repulsive force Q1 and Q3 repel, it's going to move in this direction. Q2, Q3 repel, move in this direction. So at the end, based on the force, it will go down. So if you keep anywhere here in the circle, everywhere it will experience force other than somewhere on the x-axis. So Q3 must be placed between the two charges on the same axis to experience no force. We know that force on third charge because of charge 1 must be equal to force on third charge because of charge 2. He is saying net charge is 0, so the force on this charge, let me label this as Q3, force on Q3 because of Q1 and because of Q2 must be equal. So K times Q3 Q1 over, I'm going to take this just to find out the distance where we're going to keep. I'm going to take this distance as X, okay, and I don't know the distance. I'm going to take the total distance as D. So K Q3 Q1 over X square times K Q2 Q3 over D minus X square. D is the total distance between those two, which is 10 centimeter. He gave us that value, 10 centimeter. Now, so K, Q3 get cancelled out on both sides, and Q1 he gave you Q2 is 3 times Q1. So Q1 get cancelled out. So you will end up with 3x square. So if I take this to the other side, D minus X square. D value is known, which is 10 centimeter. So you will end up with a quadratic equation. Once you solve the quadratic equation, I end up with x value as 3.66 centimeters or negative 13.66 centimeters. So negative 13.66 centimeters is somewhere here, okay, which definitely it's going to have some force on it because of both of them are positive charge. It cannot be true. So 3.66 must be the right answer. Now the next example, three charged particles with Q1 equal to negative 50 nanocoulombs, Q2 50 nanocoulombs, Q3 30 nanocoulombs, okay, are placed on the corners of a 5 centimeter by 10 centimeter rectangle. What is the net force on charge 3 due to other two charges? Okay, I believe which corner, which one, we don't know. I believe either he gave us the diagram or I chose those. Looks like he gave us the diagram, so I will go with this diagram because I can see Q1, but I'm not sure whether Q2 goes there or Q2 goes here. Looks like I got this from the textbook. Okay, now our goal is he's asking about find the net force on charge 3. So he's asking about charge on Q3, force on Q3. So F31, force on charge 3 because of 1 is k times q3 q1 over r square. We know everything, so we substituted that. I took k value as 9 times 10 to the power of 9. It's up to you. You can choose 8.99 times 10 to the power of 9. So end up with 1.35 millinewton. That force on 3 because of 1. So we're looking at force on 3 because of 1. Opposite charges, it will go down. Okay, now force on 3 because of charge 2. Okay, now you need to find this distance. That distance is by using Pythagoras theorem. 10 square plus 5 square in centimeters, 11.18 centimeter. Okay, convert that into meters here. 11.18 times 10 to the power minus 2 whole square, 50 nano, 30 nano. We end up with 1.08 millinano coulomb. At the same time, I need to find this theta. Theta equal to tan inverse of 10 over 5. This value is 63.43 degrees. Okay. Now, what is the direction of that force? Both of them are same charges. It's going to go straight in that direction. Okay, which is making 63.43 degrees angle. Okay, now our goal is finding the resultant force. So one force is directly acting down, another force is acting with an angle. So this value is 63.43. Now what we need to do, we need to find the x component of this force and y component of this force. Now you need to add them vectorially. So I did the x component f32x, which is f23 times cos 63.43, end up with 0.482, and y component f23 times sine 63.43, which is 0.965 millinewton. Now the y components are opposite to each other, so but this one has a bigger quantity, which is 1.35, and this is only 0.965. So the result is going to be 1.35 minus 0.65. Still, you will end up having some force towards down and some force in this direction. Okay, this one is 0.482 and this is 0.384. Okay, so the result is going to be in this direction. That value is f3x square plus f3y square, which is 0.617 millinewton, and phi equal to tan inverse of y component over x component, which is 38.54 degrees. That is the force on 3 because of other two charges. Okay, I'll stop this video here. We'll continue more examples in the next video. Thank you.